All right, everyone. Good morning, and welcome to the third and final day of week 2 of AI Summer. Congratulations on making it this far. I know this is a lot of people's first time, maybe programming or using Google Colab, even seeing an API key. Congratulations to making it today. And we're excited to be able to talk to you a little bit more today about agents. Just as a reminder, because I think you already know by now, but just in case you're just joining us, I'm Sharo Bell. I'm a senior data scientist here at the Data Science Institute at Vanderbilt University, and I'm also an assistant professor of the practice of computer science. I'm also joined by my colleagues, Dr. Jesse Spencer-Smith. He's the chief data scientist at the DSI, as well as the director of the DSI, Dr. Abby Petulante, Miranda Shirk, and Umang Chaudhry. They are all here to assist you as we are going through the code today. All right, so let's just jump right on in today. There is a lot to get through today, and let's just see what we can cover. So as you know, this week we have talked about API completions, the completions API available through OpenAI. And so this is just one of the APIs that is available through OpenAI. We're also focusing on the fact a little bit that OpenAI is just their API documentation is delightful. And so it's helping us to learn a little bit more about what it is to chat back and forth through an API. So we learned that on Monday. Wednesday, we really focused on RAG. We learned about vector stores. We learned about the fact that we have to divide up our documents sometimes. We learned that there are different kinds of vector stores. We learned that we do a similarity score matching between the embeddings that are created based on some LLM that we use to embed those chunks or those documents. And then the output of those embedding functions and the similarity scores, those documents are what goes into our final stage of LLM, which is the one that actually generates the final output. Today, we're talking a little bit more about tools and agents. So there's some fun things that we're going to be talking about today that come along with the ability for models to do something called function calling. It basically means in the end that there will be a structured output, which is very exciting in the case that all you want is just to be able to compute on your outputs, maybe in a more structured way. All right, so before we get much further, any questions about anything we did yesterday? Anything you want to discuss maybe a little bit further? Any questions on the homework? And I just realized this whole time I haven't had my chat window open, so let me go ahead and open that.
Hi, Shara.
Yes.
When are the notes or the classes going to be posted online for this last week? The video?
The videos?
Mm-hmm.
I'm not sure. I think that might be I think that might be a question for some of, yeah, it would be great if I had my participants pane open. But maybe some of the other folks at the DSI maybe can answer that. I'm not quite sure. That's a really good question.
Yeah, I'll look into it. I'll reach out. This should be up though.
Thank you.
Yeah, I think we've got some folks in here. Thank you, Umang. I think some other folks will be able to work on getting those posted if you don't already see them. All right, other questions? All right. So today, again, okay, what we're after is understanding some of the fundamental concepts of agents. So what drives them, what enables them to work. Some of these foundational motivating things are called function calling. Function calling is sort of this precursor thing that came before tool calling, but now they're pretty much synonymous, even though they do have this small, like distinction as to their difference. So I am going to draw that distinction today, although moving forward, you'll probably see that it becomes less and less and less important whatsoever. Also, you will be able to implement these things. Not only will we be using agents, we'll be using schemas, function calling, and also you'll learn a little bit more about the Assistance API. I have been hammering home like this one point about chat history this whole time, but the Assistance API kind of, we'll see about what special surprises that it has for us in terms of chat history. All right, so we can actually go ahead and go to our AI summer repo. I do apologize in advance. Today, there's going to be some like switching back and forth, sort of like Monday, but hopefully we will be able to manage it. So AI summer, I'll go ahead and send out a link for that. Oh, thank you, Uma. You're the best. So as we have said before, and as we might expect, here you can see some of the notebooks that we'll be using today. They're this 2_3. Something that you will notice is that there are 2 notebooks. The first one doesn't have the term solutions in there, and this one does. This is the one that we'll be working on together, but in case you get behind or you just don't want to like live code together, you just want to see it all written and think and like mull over what it is, you can go ahead and open up that solutions notebook and then just run it entirely. Otherwise, let's hop into this functions tools agents notebook right here. And as we know, we are just looking at the delightful GitHub. GitHub does a great job of hosting all of our code and versioning it. And so we know we can't run things on GitHub. It doesn't have a programmatic environment. It doesn't have a kernel available. So what we're going to do is we're going to click this open in Colab batch. And this is going to take us to Google Colab. All right, so like normal, we're gonna do our regular pip install stuff. So again, today you will need, again, to have your OpenAI API key set up. If you open this page and now you just happen to have it open, you might as well just click Notebook Access for both. And if you didn't create your LangChain API key, don't worry, you just won't make some modifications to the code. So we'll go ahead and make those available. Let's also go ahead and start running the code. So what we know is we click this run button. Oh, I remembered this time. Don't forget to, before you start running the code, just go ahead and copy that to Drive. Otherwise, you won't really be able to easily save your work. So let's go ahead and after we've copied to Drive, so this button here, we're going to go ahead and click this run. Let it run. We could also run Shift Enter. While these things are importing, so while we're getting access to LangChain, OpenAI's particular integrations with it, some other nice things that we're about to see, and I'm just going to try to scroll down. Let's see if we can sort of move past that. If we go ahead and run some of these things, all that will happen is essentially that it will wait to run these after it's finished doing the pip install. So let's go ahead and do our import of a particular package from Python, which gives us access to be able to work with our environment variables. Here again, this is how we use our API keys in Google Colab, where we use this user data thing. And then if you recall, on Wednesday, we talked about LangChain, Langsmith in particular, tracing, which allows us to see the intermediate calls to our, like in our model or our LLM-based execution chain. If you recall, like we needed an API key for that, and we made a few changes to the code in case we had an API key. So right now, if you do have an API key, let's go ahead and uncomment these two cells. Basically, all it does is it gets your API key and it sets tracing on. So that allows you to see the individual steps. And if you do not have an API key for LangChain or LangSmith in particular, you would want to leave those two lines commented. But I'm going to go ahead and uncomment. Go ahead and run that one. And if you recall, we're setting the tracing to be true. And we're also setting our project that we will essentially be recording to be the May 17th project in LangSmith. So while that is also still yet running, let's talk a little bit about the schemas. Okay, so let's roll back in our minds. Okay, let's think about LLMs and the completions that we've done and RAG that we've done. Okay, so rolling back in our minds. So whenever we got a completion or whenever we got a parsed response from the LLMs, what was the output like type? So was it like a string? Was it a dictionary? What was it? And that actually is a little bit of a trick question, but it kind of, you can justify your answer. What are y'all's thoughts? Oh, interesting. Someone I see in the chat. Oh, some people are saying dictionaries. I am obsessed with the fact that you're saying dictionaries. That is absolutely delightful. Someone said a list of dictionaries. Someone said it depends. I think that it depends answer is really the way to go because sometimes we just don't know what the output is going to be depending on exactly what it is that we have written. Often it ends up being, so it depends like where you're talking about the output, because if you recall, we had this thing called an output parser at the end of several of our LLM chains, and it turns things into a string. But sometimes you want a little bit more structured output. Maybe you ask the model for, I don't know, some Python code. And what you wanted to do is not just give you like this big old long string response, but you want to separate the response into the text portion, which is in one part of the dictionary, and then the actual code portion in another part of the dictionary. You might want that text portion of its response to have the value or the key text associated with it. And then you might want to have the actual Python code that it wrote associated with the value or the key code. So what that might enable you to do, and something to think about, is never ever just directly run code from an LLM or from just kind of anybody. But what that would help you to do is actually, if you wanted to build your own Python-based running system, you could just use the response from the LLM if it was structured like so. You could use the code response to actually just run that code and then get a response programmatically. That's an interesting point. And so where we are is that we actually have this ability through using function calling. So the basis of function calling and tool calling is that you specify certain things to the model. So if you think about even like a function, right? A function has inputs You put information into the function and something comes out of it. But the question is, what is it that goes into the functions? Is it an integer? Is it a string? Is it a keyword? Like, what is it about those values that would allow someone to define them? And then what actually is the thing that comes out? In order to specify those things and give descriptions, there is a really great Python package that pretty much, almost, I would say many of the LLM providers, LangChain, Llama Index, they're all using in order to make these specifications about the type of the information that's going in or out of a function, or what is expected from like the output of an LLM. Okay, so let's, have we done all our installations yet? All right, we've made it. So if you want to learn more, you are welcome to go to structured output here, but let's go ahead and run this. But let's take an example. So let's say that we are just, I don't know, we have a few little snippets from students. Maybe everyone in the group is going around and introducing themselves. And you know how the icebreakers are. They're like, oh, well, say your name, where you're from, and then maybe something interesting about you. And so maybe we've recorded that. Maybe we have transcribed that. And now we have these simple like interview texts where we want to create a structured version of them. So this is delightful. Love a string, love it. But sometimes we want to create that into a table so that we can actually do some computation on it. So our backing with function calling and tools helps us to do that. And so what we do is we need to specify things about how we want our output to appear and in what cases we should use this format. All right, so let's clarify that through practicing together. So one thing that we're going to do, and something that you will see at length, it's quite nearly one of the most important things when you're doing function calling or tool calling, is the fact that we need to have a description of when the model should use this particular effort. So person information, when should it go and take person information and apply that formatting? So to get to that point, what we do is we add a doc string. So that's like this set of three and three quotes, double quotes. And what we're going to do is we're going to say what this class represents. So structured information about a person extracted. So now when we get this, when the model sees this and it sees interview text, it'll think to itself, oh, that's interesting. Look, the user is specifying exactly how they want this data formatting. And because I know how to do function calling, I can return them the exact fields that they want. So now we have to specify all of the fields that we want. This maybe is some of the fields, but let's walk through what others of them, like what are the specific components of them. So we're going to add 2 more fields in order to capture the name and the hometown. So one is the name of that entire field. So it's almost like the variable name that you want to use. Then we start using this pydantic. So that thing that we just imported, this thing right here, we're going to start using that specification. So what we want name to be is a string. And we know that it's going to be a field of the input. So you can think of that like sort of like, I don't know, kind of like the JSON like definition. You can see here, Google Colab is trying to help us with our inputs about what to put there. So we're providing a little bit more extra information. If we want to, we can provide a default, which we will. There is some guidance from LangChain about this and when you should add in defaults, when you should add not. I think their general worry is that if you make it so the way that we're specifying this right now is that it's not optional. So if the model like read something and it was like, oh, I don't really see a name, it would be forced to give us a response, which can lead, I mean, when you see the model just seeming to make things up, that's what you're sort of seeing. But I think by giving it a default, we may be able to sidestep that instead. So we want to give it a default value. Maybe sometimes we want to set the parameter to be optional. That's something to experiment with. And then we also importantly want to provide it a description of what this field is. Oh. So this field will be the person's name. So now when the model looks at this schema and it's looking at this information, it will say, all right, well, the person, like the output should be a string. Great. What should it be of? A person's name. This is what they sent to me. I see a name here. It's Jackson. So I'll assign that to be name. Let's try another one. Let's do home. Again, another string. What we're going to have is a field. We'll use the same approach of default, but always keep in mind that you could set no default and also make the field optional so the model doesn't feel compelled to put something in there if it doesn't know. And then we'll add a description where the person is. Here you also see that we've already made a few other descriptions of what we have. So here we have the graduation year. Instead of a string, we have an integer. That's a different data type. It's a number. Here we also have a like a string as a job title. Finally, this is something that we love, which is delightful, which is the fact that with this specification, particularly the Pydantic specification, we can be very clear about exactly what it is that we want to receive. So not that hobbies is just one big giant string with comma separated values, but that it is actually a list of strings. Like that is the response that we want. Okay, so now that we've made the specification, let's go ahead and run that. Great. We also can start with creating our model. So here you can see we're going to use GPT 3.5 Turbo. Because we're using 3.5, we are going to leverage the component or the parameter of our LLM calls with OpenAI. So this passes through from LangChain, but we're going to use this parameter to set the temperature to 0. And sometimes if you don't do this with some of the 3.5 models, like it won't do any sort, or it won't more reliably call the function. So we're going to utilize that to create our model. And then we're going to use some LangChain functionality to actually attach this schema essentially to our LLM. So let's take a look at that. What we're going to do is we're going to use this chat model, but we are going to add or utilize this method called with structured output. It's just what it sounds like. It says, start saying to implement this if you want to steer the model in a particular kind of generation of the output. And then what we can do is pass in the actual schema that we're using, which is called person information. So we can go ahead and run that. So at the end of this, we would have a chat OpenAI model with a special additional functionality called person information, which is a schema associated with what we want the output to be structured as. Here you can see that we're about, oh, I'm actually not going to do that. Okay, here you can see that we're about to use the structured LLM. And what we are doing is we are going to input a prompt like maybe we would with a normal LLM, extract all this information. And hobbies, we're using our F string that we learned about on Wednesday so that we are taking this interview text and we're just specifically passing it in there to get a response, which is text prompt. And then we're using our functionality associated with LangChain expression language on this LLM. So this is a runnable and we invoke with the input text prompt. And then we expect to get some specific information. So let's see, let's run that. All right, interesting, fun times. Oh, let's look. So we invoked this model right on the inputs, and we get this output. And now we see again, delightful, that the output is actually exactly what we wanted. We wanted it to have this structure, person information with these fields, with these key values. And we see that the output actually is exactly that. It is, we have a name, we have a graduation year, it's an integer, we have hobbies, it is an actual list, not a one giant string that is comma separated values, but an actual list. So what does that mean? We can actually move forward with like actually computing on these values. So something that was interesting that happened, or that we participated in a couple years ago, was there was a researcher who had all of these interviews, and he was really interested in creating a spreadsheet of information. So exactly this, from all of those interviews, the hometown, the graduation year, what the parents did. And so interesting enough, back in those days, what we had to do was something called extractive question answering, which essentially means that the model will very specifically look into the text and only use the text to generate an answer. But here, this would be a different way for us to do this. Instead of us using this extractive question answering, what we could do is have an LLM behave in its normal sort of way, but guide it to actually produce these structured outputs. If you are familiar with Python dictionaries, what happens is if you run these in batch or iteratively, is that you might have a list of dictionaries. Once you have a list of dictionaries, it's essentially like one line to create a pandas data frame, and then another line to create an actual CSV or an Excel document. So the structured information it's amazing whenever you want to create the structured information out of something that's unstructured, and you want to be in control of what that structure will be. All right, let me pop on over into the chat right quick, see what's going on. All right, things are looking good. A great question about single quotes or double quotes. Python, the only time it matters if you're using single quotes or double quotes is if you're using the other one inside it. So you see here, these are in double quotes because there's a single quote inside it. I also could have switched that, but it would have been weird to have like person apostrophe, double quotes job, it would have been weird. So there we go. If you get an error, unexpected indent, it depends where it is, but it probably means that accidentally, like maybe something is indented a little bit too far. It mostly happens like if you were to do this, do you see how it's like offset? You want to just move it back and left. All right, so now in our minds, okay, we have configured the fact that there is a possibility of specifying inputs and outputs of LLMs. We have said to ourselves in our minds, okay, we have said that, all right, well, I can define a schema. The model determines when to use the schema based on the description. And then the model decides how to fill in these quote unquote blanks or fields based on the descriptions of every field. It's giving function, right? It's giving that I could do the same thing with a function. I could have the model decide when to use my function through this dot string. And then I could have the model decide what the input to the function should be if I just give it these fields. And I specify the type of the output that it should also be. It seems like it should be able to at least decide what the inputs to the function should be. It seems like it should be able to do that, give it a description of the function, and also give it a description of these fields. Well, if you think that, then you would be describing in your mind something called function calling. Okay. So again, we're going to be doing just a little bit switching around today. It's going to be a little bit back and forth. Hang in there with me. But function calling. All right, let's talk about it. So we know how our LLMs have behaved thus far, right? We have had quite the exciting week. But we know that basically what happens is that we might have an application. So that's the thing that we are writing. And this is also like sort of like a sequence. It's a diagram that helps to see like the relationship between different pieces. This is a piece. You can see it's the same like top and the bottom. It's just kind of allowing us to see like the relationship of different steps. So this is one participant in this functionality. You can see the chat LLM is another participant in the functionality. And what we see is the steps of getting a solution. So the app starting off, or us, the user, we might send a query to an LLM. So the first query is going to the LLM, and all it's going to do is respond to it. So now from the LLM side, we respond to the query. This is the standard functionality of chat LLMs. But function calling, we were just saying that maybe we have a function that we want the model to specify, just like the schema. It knew what inputs to put into the schema because we described them. And it knew that it should use that particular schema because of our description of the overall schema. Now let's try hang in there with me. This is looking like a lot. It's doing a bunch of things. But essentially, okay, what we have here in function calling, and I think Jesse did address this during the first week, so luckily this might not be the first time you're hearing it. But with function calling, we tend to think about this a little bit more associated with like a manual execution with LLMs. So the thing is, in some documentation, you will see it that function calling and tool calling is essentially the same thing. There is one little minor distinction that matters in terms of implementation, but generally you kind of can. So here I am going to be very specific and call this function calling, particularly in the OpenAI sense. So the difference from what we had before, so here is the app that we had before, a little bit longer than what we had. And here is the chat LLM that we had before. This function right here is the thing that we're trying to call to determine what to do. So here we have our normal execution, right? So what we just saw before. So the first thing that happens is we send a query to the LLM. But now what happens if it sees tools, or it sees that it has these functions that are available that it should use, is that it might look at that query and say, oh, she gave me a tool. And that tool is basically to be able to look up information online about books. All right, but she's asking me about books. So let me go ahead and use that tool. So then it will decide to use the tool. Looking at the schema that you have provided, it determines and it sends back the value of the inputs to that function, right? And so it sends them back to the app. So you, the developer, you are the one that is responsible for using the parameters that came from the LLM to call the function in the code. The code will execute, and so the function will execute because, I mean, you called it, it's in Python or whatever have you. And then it sends back whatever response to the application. And it seems like that should be the end. But often, and most times, all it is the execution of the tool. So here, after you execute the tool, after this whole sequence, all you have is like a list of books that are good horror books, maybe search from the web. But what you're missing is that LLM response, right? Because usually ChatGPT is not going to tell you like just a list of books. It's going to say, here is a list of books that you could, da, da, da. So now we need to get back to that point. So our function returns to us a response, but then we need to send that back to the LLM because it needs to complete the rest of its response. And then it completes the rest of its response and returns that to the app. So there are lots of steps in a function call. It's true. So in summary, again, we have these sort of different components. There's like essentially the calling app, which is the code that we're writing. We've also written some function to execute whatever task that we need. And so we also have the LLM that we normally use. When we have tools, we'll make our LLM tool enabled. So we'll pass it in a list of tools with those schemas that we talked about, so it knows when it should call these different tools and what the input to those tools should be. So let's say that we have an input into our LLM, our tool-enabled LLM. What happens is that chat model will look at the description of the tool. It'll look at the query. It'll say to itself, looks like I need to use this tool. It'll look at the schema of the tool that you've passed in. It'll say, oop, looks like they need these parameters. And from the query they sent me, I can add in these values. It'll return that tool call information back to your standard app. And then your app and you, the developer, you will actually call the function. So you call the function that's in your code. It executes like normal because that's what functions do. You'll get back a response. Really, this is only an intermediate response in this whole sequence because all it has is information about what happened in the function. What you want is for the model to be able to compute on this function execution. So you pass it back to the model, and then the model, based on this tool response, then returns its full query. Oh boy, serious thing. Luckily, it's awesome. So we're going to experience that now, and let's see what it is, how that looks. Any questions on that before we move forward, before we try and make it happen programmatically? Okay. Function calling it is. Okay, so now I have called this tools, but again, there is like a distinction between function calling and tools, which we'll actually see in a moment. But with function calling, you would expect to receive parameters back from your LLM as opposed to receiving the entire answer back from a tool. So here, let's go ahead and run this. I'm going to shift enter this. Okay, so you can already see that we're going to be using some tools. And so here, this should look pretty, it shouldn't look familiar because it's probably the first time you're seeing it. But again, this is a schema like we had before with person information. It's a class definition. We give it a name and we inherit from something called base model. Here, we're actually just providing a description like we did before. And we have these two, like maybe not the most descriptive field names, A and B. But here are the descriptions where we have this integer value and second integer value. I made that entire statement, but actually you would only be using this for homework. But that's another schema that you can look at. So now let's define when or how to define a tool. So we're going to use this thing called a decorator. Basically, it's a super ultra wrapper that replaces essentially whatever you're writing. So let me explain that a little bit more in a second. So now we're going to make this function. The tool that we're going to create is called multiply, because delightfully, our LLMs, maybe they don't really do math the best. It's okay, been there. So what we're defining here is that this is the name of the function in Python. Here is the name of one of the parameters. So you see it here, the first integer value. We have this colon, which is like a specification of the type. The type of A is going to be int. The type of B is going to be int. This arrow is indicating that after this whole function executes, what it should return is an integer value. And now let's give it a really nice doc string. So we're going to do these double quotes. And we're going to do 3 of them. Opening, closed. And again, we're going to give it a really good description. So you'll find that whenever you're using tool calls and function calls in schema, it is essential to write a good description. Because again, and we will see this, the model is using the description of whatever it is that you have provided to determine when it should use the tool. Okay, so if you were to just say that this is like, I don't know, a parameter for capitalizing the word goat, even though it seems to have the schema, like the model would not use it in multiplying instances, because it seems like the tool shouldn't be used to multiply, because you have said through the description that it should be used for capitalizing the word goat. So in our functionality, what we're doing is we're just going to return A times B because that is what multiplication is. And again, coming back to what this at tool thing is, whenever you see something that looks like this, it is a decorator. Basically, the functionality of LangChain adds some additional like behavior around this. If you were to try to call multiply after running this cell, if you were to try to call it like normal, like a function, you would see that it's actually kind of difficult because it's no longer this function multiply, it is this tool multiply. So let's run this. Let's see. Now we're going to define the tools that are available. So now we have made this tool. So we have one tool available, and that tool is called multiply. Tools are usually a list because often you have more than one. So we're going to have a list of the names of the tools. Actually, not even just the names of the tools, but the actual tool. So the tool is this multiply, not string multiply, but literally this is the function. So here you can see, you can see that this is now a tool. And we're also going to add this functionality of lookup. Basically, what this is a dictionary. If we pass in this string multiply to this dictionary, it will give us back this function, which we can then use and pass in inputs to multiply. So we'll see that in a moment. So now we have that defined. Okay, there we go. I think that's sufficient. And Miranda, thank you so much for that answer. I'm just going to read out what was written. So someone said our schemas and tools, basically the same thing. Miranda said a schema is a pattern for writing something, usually to keep data structured and consistent. For tools, we write a schema so that the model knows how to use the tool. And thank you for that answer. You nailed it. All right. So now we are going to create our chat LLM. It's actually already been written there for you. But now let's again enable our chat LLM to use tools. So before we had the first step of creating a structured output, but now what we have is an actual tool which we want to enable the LLM to use. So what we're going to do is we are going to bind tools to this LLM. Which tools? Yep, those tools that we just literally created, this list of tools. So now we can run this and we can explore what it is to now invoke, again, because we're still in LangChain expression language, we're going to invoke this tool-enabled function with this input where we would expect that it would call the tool, right? Because, I mean, it's for multiplication. So here, let's run this. What happens is we invoke the tool that is stored into a variable called tool response. Here we're about to see tool response. So I am now just going to scroll up a little bit. And again, if you get like maybe if you're paying attention to the lecture and maybe not able to write programmatically with us, just remember there is that solutions notebook. Go ahead, pop it on open and run it. So here from the tools response, we see something interesting, right? So maybe before what we saw is some of this stuff, but some of the things that we did not see are things like this. So here you actually see these additional keyword arguments. Now you see this tool calls thing. So one, it's just not empty brackets. So there is some sort of tool call that occurred. But here you can also see that what the tool is, right? So again, like you will see with OpenAI, it has maybe legacy code that distinguishes between a tool and a function, okay? But here you can see that the function that it wants to like complete is called multiply, and that's the one that we specified. And here are the arguments that it wants to put into multiply. So we asked what's 6 times 5. It wants to use 6 and put that into the value A. You can see that it's an integer, just like we asked, and then 5 similarly. We can also see that the finished region is tool calls. And again, we can see the list of the tool calls specifically here. And again, LangChain is a little bit iffy with it because it's not actually been like called. But here are the parameters with which we, the developer, can use to call the function. Okay, so I think there's a question in the chat about who is calling what, where, when. And so now we're about to see it. So the LLM, all it did, not all it did, because it's actually quite remarkable, is it returned us the argument to the function that we, the developer, need to call, and we ourselves can do that. So the way that we do that is we look at tool response. So this is from the LLM, the tool-enabled LLM. We can look at the tool call specifically, so this. So we see that what it wants us to do is use a tool with the name multiply, and it wants us to call multiply with the arguments, these ones. And so we can make that happen as a developer. And this is, so I'm so serious, like this is the way it works. You will write code that does this. So in our function call, all right, we look at tool response. Oh. If we look at this tool calls thing and we get the name, that is the, like literally the name of the function that it wants us to call. So let's get that first. And do you see that this is a list? It returned a list. So one should assume that you can actually make multiple function calls at the same time, or tool calls at the same time. So what this is going to give us back is the string multiply. Then what we're going to do is, you remember that tool lookup thing, that dictionary that we had before? Now that we have this string as the key, we're going to use multiply the string as a key to look up the value of the tool, which would be the actual multiply function or tool actually. So this thing here as the tool, sorry, this thing as the tool. And then since we have the actual tool, we will invoke it on something. So actually, let me just, I'm actually going to depart a little bit just to make that a little bit clearer. Let's see if I can use the same. Nope, I can't use that. Let me just break this in half. I'm going to make a new cell here. Okay, so now if we looked at fn to call, what we have is multiply. When we use this tool lookup, it will actually return us the actual function, like the tool to call. So here is the tool. And so we call this tool with arguments. And that's what we're doing when we're doing invoke. So now we're going to do something similar to this, because we need to invoke it on what the model told us to invoke it on, which is this. So essentially, instead of name, what we'll have is args. And so let's add that, and I'll scroll up a little bit more for you. So what are we invoking this on? Essentially what we just had, tool response dot tool calls at 0, which is this. And then what we want to get out of that are the arguments, which will be this. So essentially, this is the tool. It's lang chain expression language. So we're using invoke. What are we using as inputs to that? What the model said are the inputs. So let's run this. And it says 30. So someone is asking about the ID. Something you can think about is that there are multiple calls to tools. So if you think about the last time that you've tried to, I don't know, do a calculation with Code Interpreter, maybe after uploading some information or searching the web, like that's a bunch of tool calls. And so if you don't have IDs that are associated with them, like how do you, it's very difficult to reference them or assess them or change them or utilize them very specifically if needed for that specific tool call without a particular ID that's associated with it. So here we got the value 30. Excellent. So you saw kind of right then half of the steps, right? So let me just scroll back. Oop, it's almost 9:50. I guess we'll go through tools. Okay, yeah. Maybe go back. So what we did is we make this tool enabled LLM. We invoke it on something. It doesn't send us an LLM kind of response, because what we're thinking when we get a response from an LLM is it says the answer. Like 6 times 5 is 30, and you can learn more multiplication by blah, blah, blah. Like, it tells us a lot of things. Here, that's not the case. We very specifically get the output of a tool. So basically, it wants us, the developer, to call a tool. The way it tells us that is by saying, hey, it looks like you gave me a tool multiply. I can't call the function myself, but you can. So here are the parameters. It tells us, hey, I'm going to stack those together in something called tool calls. Look at that. So you can do your functionality and do the calculation. Okay, you got it. So now that the model told us that, we look at tool calls, we look at the function that it wants us to call, because we already pre-prepared this dictionary where we can look up functions or /tools by their string. This functionality gets us to the string, so we're able to use it here. Then the arguments have this particular format. That's how we can get to them. And so because we're using LangChain expression language and tools is one of these runnables, we have a tool and we invoke upon it the args that the model prepared for us, and we get our answer. However, the model has not yet seen this answer. So right now, all we have is the output of a tool call. We're still not fully, okay, so right now what we have done is we are here. Like, we've done these steps. But now we need to do also these steps. So what we have is our function return 30. And you saw that we ourselves, the developer, we're the ones who wrote this and made the answer. So now we need to put it back into formatted, we need to put it back into some sort of answer to the LLM so that it can finally give us its final statement on what is 6 times 5. So now let's look a little bit more at that. All right, so here is where we see the full suite of the timeline of what we just saw, of what we need to do. So here you need the model to actually intuit that it needs to use a function or a tool. It's not just like, hey, do this math. It's like, hey, I have 6 books of 5 pages each. How many pages do I have in total? This requires the model to recognize that it needs to actually use multiply and then also have these parameters. But then this is a case in which the model would want to like wholly say something back about the situation. Like, if you have 6 books of 5 pages each, then you will have 30 pages. Like, that's something the model would want to say. And so after we get our response of 30, we want to give back that response to the model so it can complete its entire statement. Although it's not necessary. So you don't have to do that if you don't want to. Once you have the 30, like, you might be set. But if you want to have a very chatty experience, then that's the way to go. So here we have our new query of 6 books of 5 pages each. We also are specifying our tools that we have available. And again, like normal, what we can do is invoke the LLM, the tool enabled LLM on the query and get a response. So here again, it decided that it wanted us to call a function or a tool or use a tool. Basically what it's saying is, hey, you told me I had this tool, it's called multiply. I want to use it for this purpose. And here are the arguments. Hey, developer, like, make this, like, write the code and execute it so I can get back the result. So that's what the LLM has told us. So now what we're going to do is we are going to see how it is that we add this information back into the conversation so that the LLM can actually use it. So thus far, what we have is the message is our query. And so this may look a little bit more unfamiliar to you. So essentially this is, it's another representation available through LangChain about how we can construct messages. Before we had like user, comma, whatever the query was, we can also have programmatic ways of writing that, and that's through using this thing called human message. And essentially what that will resolve to is essentially just like our user with the query. So after this message of essentially the query, we have the LLM response, the one that it just gave us. So currently that is the state of our history. Now we need to do that thing that we just did, because it asked us, the developer, to call the function, or it asked us, the app, to call the function. So now we are going to call however many functions that it tells us that it thinks are important. So here again, all we're doing is repeating the steps that we just did above. Sorry, I don't want to scroll too much. So repeating these steps for all of the tools. So here we're in a loop over all of the tool calls. Each individual tool call, we're going to call tool call. So for a particular tool call, we're going to get the name, and we're going to store that as called tool name. We're going to use our dictionary that gets the tool, the callable tool, from the string of the name. So this is the string of the name, and we do our lookup. So this is the actual tool. With this actual tool, we're going to invoke it on what the arguments the model said that we should invoke it with, and we'll get the tool output. And then the last thing that we need to do is add this to the message history, because as we know, we need to have the entire chat history at all times if we want to send the full conversation over to the LLM for processing or a response. So let's see. What we're going to do is we're going to go ahead, message history. That's this thing here. We need to append to it. That basically means, hey, could you add this other element? What we're going to append to it is something that we haven't seen before. It is something called a tool message. And essentially, it's this thing right here. So the thing that the tool computed after we called it. And then someone was asking about the ID. There we go. This is the moment in which we use it. The ID of the tool call as well. And I spelled that incorrectly. There we go, tool call ID. So now for each tool call, it's exactly what we said. We're essentially getting the parameters from the LLM. It's prepared everything from us. The only thing it didn't do was literally call the function. So now that's our job to be responsible in our interaction with this LLM. We are calling the function for it, adding based on the inputs that it provides us. And then we're saying we're updating the message history to say, by the way, we did call these tools, and here is the output. Then we can view this message history. So this is us just looking at what this now looks like. So we added our tool message. So this is new. You could see that the content is 30. Now with this whole information, we send the entire conversation back to the tool-enabled LLM in order to get our final answer. And so now you see the response that you would see through something like ChatGPT, because it wants to give you like a narrated natural language response instead of just like the tool output. And you see that what it says is you have a total of 30 pages in 6 books of 5 pages each. And so this is just the end of that turn. You see the finished reason was stop. And so this is what the entire cycle of a function call looks like. It's really cool. It was so cool to see this when it first came out, because it's so powerful. Like, not only do you have the ability to create different schemas so you can have structured outputs, but now actually you can have the model prepare these inputs to your functions. I think when it mentally, it sometimes sounds trivial, but it's really interesting because to create inputs for a function is something that's really difficult, because the user has to first tell you something, and then you have to extract the relevant information out of that and then prepare it in the right sort of type to send it to a function. And so this is very cool. It's been used a lot with like websites. I saw somebody use it with like Google Drive. Essentially, they read everything that is in their grocery list, which is prepared through using something else. And then it does like these calculations. It's loop chaining these together is actually just it's very fun. All right, so now that we've talked about function calling, I think it is 10 a.m. So let us take a quick little 5-minute break before we come back and talk about agents. It's also going to be really cool. So I will see you in 5.
Charu, can I ask a question?
Yeah.
So is it, I mean, this is really fascinating. The way I see it is that we know that LLMs generally aren't that great at math. So you've basically given it tools to do math. 2 questions. You never used the word multiply. So in the olden days for programming, if you said my function call is multiply, but I use the word multiplication, it'll give me a syntax error. Is the point that, or it'll just say I can't find that name. Is the point here that the LLM has done something to say, okay, determined that they want us to do the user wants us to do multiplication. Let me search if there's any tools that are similar to that word and then invoke it, or what?
So it says, it looks like the user wants me to call, it wants me to do multiplication, and then it looks at the doc strings. So all of the descriptions that are available, it reads them, and it's like, that one right there, they said to use this in the case that I have 2 integers A and B, and they need them multiplied together. And so it's not looking at the name of the function so much, even though that can be a piece of it. It's really looking at those doc strings that we have written, those descriptions that describe when the model should use this particular tool.
So it knows what multiplication is effectively,
From
but it
our
doesn't know.
description.
Oh, from our description. Okay.
Oh, wait. I think I might have interrupted you before you said the thing that you were going to say. Can you say it again?
I guess I was wondering, how does it know it's looking for something that, obviously from the language that was the prompt, it knows there's that effectively it has to do some multiplication. It doesn't, and then how does it determine that if it's not using the word multiply or using the function call? You're saying it's actually using the doc string. How does it know that doc string is actually a multiplication function?
So it really depends what we put into the doc string. So something to experiment with is if you write a really good description for a tool versus if you write like a bad description for a tool. Because often if you write like a bad description, which is like what we wrote was multiplies A and B. The args A is the first int and B is the second int. And so if we were to write adds together A and B, then it would, if it saw addition, then it would try to call this function multiply because we said to use it for purposes of addition. So it's like that description that defines when the model will do any particular thing. The thing is that these models are specifically trained for function calling. So like out of the box, like a model like will not just be able to just straight up do this function calling thing. It won't just decide that it needs to look at these tools. That model has to be trained to do function calling.
Okay, so when you say the model, that was going to be my next question. How is the model trained to know, hey, this is a time where I should probably check to see if I have a tool that's available versus, oh, I think I can figure this out on my own. How does it, you're saying it has to be trained to know when to do function calling? And so how do you do that?
It has to be trained to determine when it should look to see whether it has available tools and then to sort of return them. But it's like a training exercise, like the other kind of scope of training exercises where we are just telling it like when is an appropriate time. We have a training data set of when it is appropriate time to utilize like a tool.
And it's already been fine-tuned on that training set?
Yes.
Is that, which model did we end up using? I sort of lost track. Like that's what model is fine-tuned on that? Because that seems like, is it a Hugging Face model or?
So the model that we're using is 3.5 Turbo from OpenAI.
Okay, so we know it's already been trained on looking for tools.
Yeah.
Okay.
There's some of them who have not, and they have like a small list that's on LangChain. If we look at LangChain, since they're so general, they're like a generalized integration specialist and functionality specialist for LLMs. They have a description of which models do tool calling versus which ones don't. And it is something that you really have to train the models for. Otherwise, like if you use one that doesn't do tool calling, it will just completely ignore everything you have to say. And you're like, that was weird. but it just
Okay.
means like switch to tool calling.
So realistically, we're never going to have to train it on to become a tool calling model. But I guess my next is would we ever have to be concerned if we wanted to do, but could a model be trained on math tool calling, but we needed to do, say, logic, which is another thing that LLMs may not be good at? Can we assume that GPT 3.5 is good at function calling for both math and logic?
So 3.5, so the reason I'm just using 3.5 here is because it is like much cheaper than the other models. We would see a distinct increase in performance if we use GPT-4. It's much better at, I mean, reasoning and more complex tasks because they've trained it to be so. And now I suddenly lost track of what I was going to say
Well,
about that.
we were talking about function, like, can they pick, can a model be good at function calling a specific thing like math, but not logic? Or can we assume that if it's function calling good on one, it's good at function calling on all of them?
So that was a good, okay, there we go. So in the documentation from some providers, they like to say that sometimes you really, especially with models that you yourself did not train, so something like 3.5 turbo, and that doesn't have like overwhelmingly great reasoning skills. Like for those, you have to write a prompt that is so intense and long and specific and detailed that it becomes nearly prohibitive in the actual distance of the prompt.
Okay.
So what they say is if you get into the situation where you have to write these really extreme prompts to force the model to use this tool and to execute it like the way that you want it, that is when you want to create a fine-tuning data set to have your model learn when to use the tool so that you don't have to have this really extremely long prompt at the beginning to specify every single little piece of minutia about what it needs to be thinking about. I will say that I do like in observing sort of the history of LangChain and function calling, OpenAI and function calling, what I've sort of seen is that some functionality is really developed in response to maybe some of the things that the model is not good at. And so we see a lot of capabilities that are around making the model more performant. But as the models become more performant, like for like GPT-4 Omni, like GPT-4, it seems to invalidate like a good set of things that were made in order to meet these deficiencies. So I think although this is the way that it's like being done now, like it could, I mean, I definitely expect it to change in the future because the capabilities of the models are just like stepping up and up and up and up.
Excellent. Thank you so much. I took away your break time, sorry.
It's okay. Totally okay. Let's jump right on back in. All right, and let me set up my new screens. It's so interesting because everything usually stays in the same place right until I stop screen sharing. And then it's like, let's all move around. Time to dance. All right, so agents, gosh, this is gonna be really cool. I hope you guys get as excited as I do about this because I remember the first time I saw this, like, I don't know, I might have gotten up and like did a lap around my house. It was just crazy. All right, so let's talk about what we have seen thus far. Okay, we're gonna think back. We're going to think back to RAG. We're going to think back to our completions API. We're going to think about that really, the multi-step tool call that we just made. Okay, we're going to think about that. What we have been using thus far is something called chains, right? And basically how our chains behave is that we have some input, and from that input, a tool-enabled model or a retriever model, they're going to look at what the input is. They're going to essentially say, time to do blank. They're going to decide what to do, maybe use a tool, maybe not, but they're going to do whatever they're going to do, and then it's sort of over. So you give it a question like, what happened to Han Solo in Empire Strikes Back? It's going to take that input. It is going to parse it. If you have tools for web search, be able to look it up on the web. If you have a retriever as a tool, maybe it'll use the retriever. Whatever the case is, it will do that one thing, and then it's done. Agents, however, are very delightful in this. in the sense that what they will do and what they can do, depending on the kind of agent that you're using, is you can ask a question, and then this guiding agent can sort of execute a bunch of parts to make sure that you get to the answer. In other words, instead of just running one tool one time, it is looking at the different steps that it needs to take, and it is running this iteratively until it gets you to a final response. So it might just not be one tool, it might not be two tools, it might be these tools in iteration until it is decided that it has actually reached the answer, which is super cool. So let's see what this looks like. All right, moving right along. Okay. You can see something interesting that we are about to use. Like, I mean, we're already doing LangChain tools, DuckDuckGo search results. What? You can see from agents, we are using something called Agent Executor. We're going to be looking at a React agent and a tool calling agent. These ones are just some agents that are available through LangChain, but they generalize to other platforms. There are just so many different kinds of agents. It's a whole case unto itself. All right, so let's run this. Okay, let's come back to creating our tools. So we're going to create a tool for an agent. We're going to use a built-in tool from LangChain, and you just saw that we're using these DuckDuckGo search results. So what this tool is it's going to use DuckDuckGo to go ahead and search the web for us and give us a result. Okay, so let's try it out first. Okay, so this is just running the search. This has nothing to do with the LLM. All we're doing is creating this DuckDuck search results tool, and then we are running it based on some input. So let's run this. So here you can see that what we've done is we have searched the web. The question was, how many children does Barack Obama have? That was essentially used in the DuckDuckGo search, where we have this answer. So that's a nice tool. Again, all we are here is using the tool. We haven't even got the LLM in there yet. So like normal, what we do is we create a list of tools that a model is able to utilize. Here, we're just going to give it this search tool. And then we're going to create our LLM. Do keep in mind here that they don't, this, like before we had this bind tools thing. The assumption with an agent is that it will have tools bound to it. So we'll pass in the chat LLM, and then LangChain or whatever platform will handle the rest. So here we've created our search LLM 3.5 Turbo. We have our tools prepared. Now we just need a prompt to help us. We're going to go ahead and write this prompt. Essentially, we have a nice system prompt to help us. Sometimes, and so I think we were just talking about this during the break. It depends on how capable and knowledge and like reasoning enabled that your model is. Sometimes you have to write a really long system message to get your model to reliably use a tool. In those cases, you might want to consider fine tuning. But here we have our system prompt. We have our human prompt like normal, and we have this thing that we've never seen before, which is called Agent Scratchpad. But what we have seen before is the concept of a placeholder. Before we had messages placeholder, we wanted to add the conversation history. Here we have a placeholder for intermediate results from the agent. Crazy. We'll see what those are. All right, so here's the full prompt that we're using. We also have an agent that we need to create. Let's see how we're going to do that. The first kind of agent that we're going to start with is a tool calling agent. And again, I have provided some resources at the top. Oops. So I provided some resources at the top so you can look and see the different kinds of agents that are available. So right now, the recommended agent to use through LangChain is this tool calling agent. So let's take a look. What it wants from us is, you can see here, this language model. It wants us to pass in that list of tools, and it wants us to pass in that prompt. So we are happy to do that for it. Let's do that. We're passing in search LLM as the model, the list of tools as the tools, and the search prompt as the prompt. Although we created this agent, we still need to create something called the agent executor. And so that thing is like a hierarchy above like what a normal agent would think of. even when we think about the function calling functionality that we just wrote, what we see is that there is something that needs to actually run the function. So although the agent might be able to, or although the LLM in particular might be able to tell us what function to use, and the arguments, something above it needs to create the logic of totally what it needs to do, as well as be able to do these little intermediate things to glue the entire system together. So that's the agent executor. So let's create one of those. It needs an agent. So we can do lots of things, as we see here, lots that is possible. But we are going to pass in the agent that we just created, the tools that are available. We're going to add these other, okay, so number one, you can see some interesting things here. One, we have the ability to return intermediate steps, which would suggest that there are intermediate steps. So we're going to see something other than input and output. But also we see this thing called max iterations. That is because our models will love, they won't love it, but essentially they don't just execute once. They might just run over and over and over trying to get to result. So sometimes we want to set the maximum iterations to be a value. That is a value, that is something finite. We also have other parameters like verbose. This is going to tell us more about the behavior of the model while it's executing, as well as, so we're going to use that verbose true, and we're going to return intermediate steps true. All right. So now what we have here is going to be an agent. So not just the search that we saw above, but a full agent with the agent executor. So let's run this one. And now let's just casually see what happens when we allow it to use this search tool to answer the question, how many children does Barack Obama have? And let's run this one. So one, we have return intermediate steps true, and we have verbose. So that's why we're seeing a lot of things. But here you can see that a true tool calling instance. So not a function calling, but a tool calling. At no point did we need to intervene and be like, all right, well, here are the arguments. Let me write this. Let me write that. This is the true behavior of what someone might call tool calling. The model on its own, or the agent on its own, actually gets the inputs that it needs to run the function, runs the function, and then returns you the entire answer. So this is what we might refer to as tool calling, and we can see this here. This might be a good moment to go to Langsmith, but I didn't paste the link here. I didn't provide that as a link, so let's hope that I can remember the URL. I think that it's smith.langchain.com. Ah, perfect. So I can paste this over here. Oh. How does oh God, that's such a good question. Someone asked, how does the agent know when to stop the iteration? That is such a good question. And that question is particularly good because also it depends on the agent. When the agent is done, it is forced to, maybe not forced, that's kind of an ugly statement, but it emits like a particular value. So it has like a stop iteration sort of value. Usually it's called agent finish. And whenever it's done and it's finished, it says, hey, either final answer, or it gives some sort of signal that it's done. And then that is when the chain actually finishes. So let's look at that. Let's see if we can get to it. Wow, there are literally 8 here. I don't know whether I was expecting that or not. Yeah, I guess I was. So here's the thing that we see. This is what we just ran. This is the agent executor. Here you see a lot of stuff. So we were talking about on Wednesday, these runnables, these chains. We were talking about, again, these runnables, these chains. Here goes that tool that we called, looks like a wrench. So if we want to see in totality, so being on this little button here will show us the entirety of the run. So here was the input. And then the entire output is this. And you can see some of the response. So here is the actual, I mean, this is like It's a lot to kind of look at, but you can kind of like see what is meant to happen here. We have this sequence. So you see the scratch pad where it's sort of thinking in terms of intermediate steps. We have this chat prompt template, which is the one that we created with the intermediate steps with the scratch pad. You also see, I always look at the end of the agent parser. You can see that at the we decided that we essentially needed to be able to call DuckDuckGo results. So after running this, okay, let's go to this one instead. All right. So it knows that it has these tools available. These are the inputs to the system, which are your helpful assistant, this, that, and the other. And we saw that. And we also asked how many children does Barack Obama have? This here, we see the actual query that it prepares, but it also does the calling. So here we can see that the input is this. Here we see the output of the tool agent parser, though we also need to actually run the results with these inputs prepared from the previous stage. And here we get the output results. From there, it does do a little bit more thinking, but then we can look at the chat prompt template because this is sort of after the runnable steps to see what the input is and the output. So here are the previous messages with the fact that we needed to use the tool, the output of the tool, and the output that it is using. This is our second sequence back from the tool call. We're not scrolling, but here we can see that this is going to the model. Then this is answering the question. We do have this agent parser, but we still have the same output. So that's something to look at, like a little bit like more depth later. It's a lot of steps that you just kind of have to wrap your head around. But at any time, you can look at them to help you understand what has gone wrong and what has gone right, especially while you are debugging these agents. So if you decide to make your own custom agent, you will be sitting here for a long time trying to understand why exactly things are, maybe not a long time, but you will look at a trace like this to try to understand what has occurred and why. So here's our first run. We get the input to the tools. We actually we do the tool calling, and then we do that second round to get the result. But all of this is automated by this agent executor. All right, so now that we have a general basis about what's going on, what's happening, let's try more tools. So now we're going to go and use our own custom tool that we have written. So we wrote multiply a little while ago. So let's go ahead and use that. What we're going to do is we're going to pass in a list of tools. As normal, we're going to use search and multiply. And then with this agent, we're going to create again a tool calling agent where we're passing in exactly when it wants that search LLM. Passing in the tools that are available, which is now this, and then a search prompt. So do keep in mind that we're using 3.5 turbo. And again, you might see in this next execution why it is that LLMs that have more capability end up being better agents because, I mean, they have more capability. But let's see sometimes. So you'll see this line here, which is not making any sense, but essentially you have to do very specific things. Sometimes if your model is deciding not to do certain things. So what the intended behavior of this agent would be, the question is how many grandchildren would Barack Obama have if each of his children had 2 children? The objective here would be for the model to go use DuckDuckGo search to see how many children that Barack Obama has, and have that number be 2, then invoke multiply function to multiply 2 and 2. But when I was experimenting, basically it didn't want to use a DuckDuckGo search. So now we're trying to force it to use that search in the query by telling it that something happened recently, which would prompt the model to want to go and do the search. So again, this is a moment where we might want to step up to GPT-4, but a little bit expensive. So that's why we're not going to do that here. So anyways, so now we have the tools. We're creating a tool calling agent. We have our agent executor. We're looking at the intermediate steps. And now we're going to go ahead and invoke this on this. trying to have the model really go use DuckDuckGo search to determine how many children that this guy has, and then multiply that by the number of children that they would have to get the total number of grandchildren. So let's run this. You can see the new chain is running. So hilariously, it really wants to start with just doing this math, meaning that it's not really trying to look up first how many children he has, but it does end up looking up whether he had a recent baby or not. So maybe a little bit of a nosy model, but we can see that, yeah. So here we have these results, and we see that what we wanted to see, even though it's not exactly how we wanted to see it. But essentially what we see is the model is able to execute multiple steps, right? Because before it might want to do multiply. It might want to do DuckDuckGo's results. But it's hard to have them be in a sequence and execute until the model has felt like it is done with this processing. So someone asks whether you can dictate the order of these steps. If you really, really, really want to dictate the order of steps, something to do would be to go to the chain implementation, because the chain implementation, so back from the agent executor, is where you must specify the order of the steps. There is some capability to add branching and logic like that. But, and you can also hold on, in these, in the system prompt, and like in the prompt that we pass in, you can also provide guiding behavior. So maybe you could say, before every, question about people, you go and search the web, then you da-da-da-da-da. So you can give it guidance. But if you really want to be strict in that guidance, you can program it to behave in a certain way by using chains. All right. So actually, like, although we have retrievers that are really exciting and wonderful and delightful and all that great stuff, we could also cast them into not just like this, language chain expression language thing, but as a tool. So not that the retriever always runs as it did with the chains, but something that the model looks at and decides whether it's going to use, which is awesome. So here we're going to actually use just essentially the code that we did yesterday or on Wednesday. Here I am using A New Hope again. So what we're doing, just as a reminder, is we're reading from A New Hope from the website. We're only taking a part of the content. While we're reading, we're also splitting into chunks. Chunk size 500, chunk overlap 100, and we are adding the start index so that we are able to see to perform like a more citation-based behavior, even though it's not a real citation, but essentially whenever we return a chunk, we know exactly what document it came from and where that chunk is in the document. So we're going to load and split to create our chunks. And then from those chunks, we are going to create some embeddings. These are going to be using Hugging Face embeddings. We're going to use mini LM. We're going to use a face vector store, which comes from Facebook. It does a certain kind of lookup. Again, something that we know is that our vector stores influence the kind of similarity matching that we do. They impact the speed of the processing, and it also impacts the kinds of similarity measures that we're able to use. So from there, we create our vector store. From our vector store, we treat it as a retriever, meaning that we add some additional functionality onto it to bring it into LangChain expression language as well. And also we're able to add any keyword arguments that we find are important. We're adding the number of chunks to return here, although something better in general would be to add a threshold on the similarity score to modify the similarity score function and things like that. So really, while I was talking, what I should have done is run this first and then started talking, but now it's too late for that. But essentially, we read from the web, and now we're creating our embeddings. Again, something to notice is that from RAG, what we know is that the LLM that you use to answer the question does not need and probably will not be the same as the model that you use to do the embedding. These are two different models. One is usually an embedding model, which is trained to make good chunks for embeddings and retrieval. And then your LLM is based for generation so that once the chunks are retrieved, then they go into the second LLM, and then the LLM produces a generated response based on those retrieved chunks. All right, so now we've created our retriever. We want to cast it as a tool instead of just like a retriever. So this is something that the model decides to use when it is important. So what we're going to do is, we know that models decide to use tools based on their description. So we're going to create what we've already have written here. We're going to create a name for the tool that will is usually passed to the model depending on how the agent is executing. And then we're going to pass a description to the model about what this tool is. A little empirical commentary. Someone asked about capitalization of certain words to emphasize things to the model. I tried this over and over and over in the past to make it work, so that the model would go and use the retriever. In this particular situation, we're talking about A New Hope. It never worked until I capitalized must. Okay. So now that we have the tool name and the description written out, we're going to go ahead and create our retriever tool. You can see the kinds of things that it wants. It wants a name for the tool, and it wants a description of what the tool is. Okay, then we'll give it exactly like what it wants. We've already passed in the retriever. Let's pass in the name, and we said that that is tool name here. And here is also the description of the tool. All of these will be used to create the retriever as a tool instead of just the regular retriever. So let's run this. Now we're going to update our tools such that we have the retriever tool added. So we're going to keep with search. Search, it seems like it would be really helpful for us, even if we do have the retrieval tool available. Retriever tool. So we're going to run this one too to create our list of tools. And now I wanted to introduce you to a different kind of agent. So this is called a React agent. And so you can read more about this. There's like a whole paper about it, but basically it goes through this line of reasoning as it is executing its tasks. And I just really love to see it execute. So that's why I'm always looking at it. It has reduced functionality compared to your tool calling agent. It still can call tools, but I like to see the reasoning that it does. And so the reasoning that it does is essentially forced through the prompt. So you can see that whenever, we can see that there's tools available. You tell it what tools are available. In fact, you specify like the actual tools, like the functions. And then here, there are tool names that are available. But otherwise, you have this full prompt, which is like about the React behavior, where you wanted to first write a question. So the question that, based on your query, the user, then the agent should formulate a question that it thinks that you are asking, and then it should come up with an idea about what to do in response to that question. From there, it should decide what action to take, and that action is based on the tool names. Based on those tool names, not based on the tool names, but thinking about what the tool names are, what should be the inputs, so preparing according to our schema, what those should be, and then after it executes its action, what is the result of the action? If it needs to go in this cycle a little bit more, it can, to determine what to do and what other steps that it needs to execute. But otherwise, at the end, it will say, I now know the final answer, and then the final answer. Someone asked about how these models decide to stop, or when is the stop criteria. This final answer thing from a React agent is the stopping criteria. When we see this final answer keyword, that means, hey, the model's done. It's already made its decision. So here you can see a full React prompt where we're creating from a chat prompt template, just like we had before, the message placeholder, which is a chat history. We'll come back to that. And then we're using the human message, and we're using the React template there. So this is a little bit of like different syntax, but it's literally the same thing that we've been doing this whole time. All right, so we create that called the React prompt. And I need to move right along with this. It's okay, I think we're getting close to the end. Here's the React prompt that we've created. So now we're creating a React agent I love to see them execute. I think the reasoning is so interesting. But again, this kind of agent was made, I think, in like 2020. Oh my gosh, it's 2024. But it was made in 2022. So maybe not that long ago. But I think with some of the functionality of some of the new models, perhaps, I don't know. We'll see how relevant or useful that it continues to be. But even just being able to see the actual behavior of the model as it is reasoning, I think that's actually very powerful. So now what we're going to do is we're going to create a React agent. It wants the same thing, the model, the tools available, and the prompt. We're using the React prompt. Now we're going to create our agent executor as normal, still returning all the intermediate steps so we can read them. Let's run this. Now we can invoke this function or the agent. We'll call the agent on some input. What will that input be? Maybe what happened to Princess Leia in A New Hope. All right, let's invoke this, keeping in mind that the directionality that we gave to this agent with the retriever tool is if anyone ever asks any questions about A New Hope, then you need to use the retriever. So here we see this React chain and what the model is doing. It's saying my first initial idea is that I should use this information retriever for Star Wars movie. We, as the user, said, again, that you must use that to find out what happened to Princess Leia in the movie. We see what action it's doing. So this is using the retriever. And then it is using this as the query. And then these are some of the results that are returned. Now it comes up and says, I know what happened to da-da-da, and here's the final answer. That is like the signal to stop with the chain. So here, blah, 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 blah. Oh, yeah, she's right. So now after we have seen this response, then it formulates its actual output that it wants to say. All right, so someone asked, is there a harm in defining more tools than you may need? How careful should you be with this? I think the challenge may be in the actual model performance. The model may see like all these tools and then just start picking the wrong ones because it has too many choices. In complex cases where you have many tools, yes, the model can be confused about which ones to. So not to overstate my, so let me read it back. In complex cases, where you may have many tools, can the model be confused about which one or ones to use? So yes, in the past, I have used tools where I have multiple retrievers. So instead of using I have each separate retriever for like a different movie or blah, blah, blah is a separate tool. And especially when using something like 3.5 Turbo, sometimes it was confused in which ones to use. But the documentation that we have seen through OpenAI would suggest that if you're really having trouble with your model not being able to distinguish things, start with a really great long prompt about how to help the model distinguish things. Also, if your model is having a really bad time deciding between tools, you want to be as explicit as possible as you can in your descriptions. Right now, they're sort of limited to a length, I think. That might be only true for some platforms, but you want to be very specific in what guidance you give in your descriptions to when the model should use different tools. Like that is like the most important thing about using tools. Maybe not the most important thing, but it is a huge signal to the model about when to use that tool. With the React agent, maybe we can look at this a little bit to expand upon it. So let me refresh that, just making sure. Oh, that's not really what I wanted. This one. I'm gonna have to take a second and remind myself where this appears in this execution. But here we can see that the initial run, we see where the retriever is actually called. So I think it's actually up here. maybe it's easier to see down below. Oh no, it's right here. So this is one of them. Maybe it's easier to see. It's okay. We're just going to use this one for now. So here you see the tool. Do you remember our prompt? It says answer the blah blah meaning response possible. You have access to the following tools. That is in the prompt that we wrote. This is actually the specification for that tool DuckDuckGo search results. Like this is like the information that goes with it. Here is the information that we wrote about our retriever. That was the name of the retriever that we gave it. This is the description of when to use the tool. So you see that it appears in the prompt. So again, like if you see that your model is like, I mean, ultra struggling to decide what kind of tool to use at any given point, one, use a more powerful model, but two, it comes down to what you have done to try to help the model to decide what to do and when. It also sort of depends because sometimes it'll put the entire it will put all, I mean, you can use more elaborate doc strings. So for us, our first multiply function had almost, I mean, it was like almost the entire functionality there. That's something that you can also do to try to elaborate on what your tool is actually doing. All right, I'm going to try not to keep you much longer, but let's, oh, no, we're not going out there. All right, so we can try another query. And so this is a little bit of testing where we would expect to see that a retriever is used to ask, to answer a question about Luke Skywalker, but then a search would be used to ask, to answer a question about The Empire Strikes Back. And we would expect to see that in some different fields or some different cycle steps. So let's see what we can do there with that. Maybe the query that we use is, I mean, what we've written here. So query. Let's run this one. We have written verbose, and we have also done return intermediate steps. So every single thing that we see is going to be super long. It's okay, at least it's colorful. Oh, this isn't super long, it's just sort of long. So here we see a user retriever first. This is the information that I got back from the retriever. Excellent. DuckDuckGo results. We see that it did use a different tool to help it. But here we kind of see that maybe, I don't know if it's fair. So what it decided to use essentially as the search is influence of Obi-Wan's actions on Luke Skywalker, A New Hope, and The Empire Strikes Back. Interesting, but you see that it did search the web to try to find an answer. And so here it actually generates those answers. All right, so we have been harping on this whole time that we need to have a chat history. We need to manage it ourselves. Otherwise, oh, I'm just trying to find it. We need to manage it ourselves. Otherwise, we're sending individual statements to the model. All right, so unless we manage our own chat history, it is unfortunately the case that it won't ever remember anything that we have said before. And our React prompt, we already sort of built in the ability to use chat history, despite the fact that we actually haven't used it yet. But next we will add in how we can use chat history with our agents. So what we will do is and also this is kind of a way to demonstrate how to work with chat history, but I would not, the way that this is implemented is maybe less in line with software engineering practices because it's using these sort of global implementations, which aren't for the best. But it does demonstrate how one might utilize chat history. If you want to implement this in a more software engineering framework, you would reformulate how this looks a little bit. But essentially, the principles stand where we have a message history, and at all times, the runnable that we create with message history, just like we did on Wednesday, it will always need some message history to utilize. So here we create an empty one. What we can do is we're again creating our runnable with message history like we did on Wednesday. And so what we're going to pass in instead of an LLM is going to be our most recent agent executor. Is that you? Okay, great. Again, passing in the message history, which is going to be loaded from here. We have some keys about what the input will be in the chat history. And here we have this handle parsing error situation, meaning that sometimes when you use tools and sometimes with runnables, they have an output that doesn't actually conform to what the input of the next step needs. And so here it's being instructed to handle the parsing errors in those cases. Does it always work? Not always. So here we're going to go ahead and run that. We're going to create our agent with chat history. So now what we're going to demonstrate to ourselves is in this first query, this will be our first statement. So we know that we need to call invoke like normal. We need to have this input. And that's going to be called this query. We also know that from before, we managed our different notions of threads in the sidebar with this session ID. And so we're going to use session ID 1 here. So here we're going to pass in this first query. The first query is the question that we just asked a second ago, or maybe it is, don't remember. What did Obi-Wan do for Luke Skywalker in A New Hope? How does this influence blah, blah, blah. So here we can see that it's returning some information about that. But now, okay, let's see what it says. Led to the revelation of Darth Vader as Luke's father in The Empire Strikes Back, creating a pivotal moment, blah, blah, blah. So that's exciting and all, but maybe we want more details. So in a chat form, we want to ask the model to elaborate on the previous answer and demonstrate to ourselves that it will elaborate because otherwise there would be no previous answer, provide details that reference the object that Obi-Wan gave to Luke in A New Hope. So here, let us go ahead and add that new query to our input. Query 2. And here, the rest of our configuration is going to stay the same. Although, okay, there we go. And now let's run this one. So one, we see the chat history in here. And we see our next message, which is the output here, and blah, 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 which is blah, 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 blah. So we see an answer. However, these two are kind of distinct. And so it's kind of hard to believe maybe that there is a chat history. But when in doubt, we can always come back to Langsmith, who is tracing all of this, and we can view this in a way that maybe is more pleasant for our eyes. So here we can look at this insert chat history, or actually we can just go look at the agent executor, and we can see the full input after the history is loaded. Here, this is the input that we gave in the second chat message, but we also see the input from messages, which are these first few pieces of the conversation. So we can know that these are actually going into the model on the second chat iteration. All right, two last pieces. Let's see if we can fit them in. Hopefully I didn't remove any lines because I don't think I was going to type through this one. But something interesting is that, again, we've been talking about how to implement these things, but the fact is that a lot of times the actual API part that you're using can be a small part of the overall functionality that you wish to create. And so here what we're going to do is we're going to experiment with that just a little bit more. This is, we didn't get a chance to do this on Monday, maybe we reviewed it over the homework, but essentially this is a user interface, the entirety of the specifications for the face of a user interface with Gradio blocks. So you'll see that we have a chat box, we'll have this text box, we'll have a clear box, and we'll have this ability to send a message to the chatbot and get a response. The actual code that we'll be using here that is specifically using the API for LangChain is this one line. But even this one line is just, it is a small part of this overall behavior. The rest of these lines are really just, they're towards formatting and they're programmatic things. But this is where we actually do our interaction with the agent. So let's try that together. Let's see if it's working well. So here we have our message history. We're going to clear it first. And we're going to essentially start a new conversation, although this doesn't technically do anything because of the way it's implemented, but that's okay. So now we're going to run this. So now we have a radio user interface, a very lightweight one. This will show the chat messages. And this is where we're going to input our information. So right now, the agent that we're talking to is that retriever search one. So what happened to Luke Skywalker's family in A New Hope? We're going to press enter to send that message. So right now we have this nice chatbot functionality. This is what I just sent. This is what the model just sent back to me. And now we have this very chatty approach, even though literally like so few lines of code. That's okay. Let's see, since this should be a chat implementation, we're gonna see what else we can do there. Why were they looking for R2-D2? And this is exactly chatty as we would expect. So on my computer, it does something a little bit different than this, but this is exactly how the functionality that we would expect is looking for. It is a little bit more, we have the outputs of the executor on my computer, but let's look at this one. You can see that we have four pieces here. I mean, actually it's technically two. So here is that first message that we sent. And you can see the execution here. We had a retriever called. And then here, yes, just the retriever again. But you can see that we had the chat history. So tons of functionality sitting behind a very trim looking user interface here. So even this beginning shows us that we have a lot of power available for us, even with a few lines of code. One last thing, we're going to talk about agents just a little, to our assistants, OpenAI assistants, just a little tiny bit in our last 8 minutes here. We might not have time to actually get to the code, but let's go to the playground first. And we can click on that link there. All right, so here is a playground. Maybe what I will do is I will start by creating like a blank assistant. What we can do, and maybe since we just have the 7 minutes, you can just watch for now. I'll explain what's going on. Something to notice is here is an assistant. We are creating this assistant. It has a name. And with that name, you also have an ID. As normal, you have custom instructions or a system message, and we select a model. What is different is that now we explicitly give it access to tools. This should sound extremely familiar because literally that agent executor that we just made, we gave it a retriever vector store, and that is precisely what this is. And so now this assistant decides when it should use the retriever. These are enabled at the global level. So throughout the entire, like the assistant itself will have all of this information. We can also choose to enable code interpreter. Code interpreter does analysis, it runs Python. And we can also have custom functions that we add. What you learned at the beginning with function calling will be very helpful here. You will also notice that with file search, with this tool, we also can add specific files. You also see that when we add the files, it is likely that we will also be able to utilize a vector store. Same thing here. And then when we go to the playground, so number one, something to note is that this was created, even though I didn't say like submit or anything like that, like it was just created. Do you remember that's what it's going to look like in the API? Looking at the playground, again, we have our assistant ID, instructions model, file search, able to associate functions at the file search and code interpreter at the global level of the assistant and functions. So this thing in which we converse is called a thread. A thread. You remember all of this, oh, you need to manage your whole conversation history, like you have to send it back and forth every single time, like it's like you need to add it, otherwise you won't remember. Eliminated with the Assistance API. A thread is literally a thread of conversation. If you send it one message, it will remember the rest of your messages. So surprise. Also Gemini is like this, but this is true for agents. Otherwise, you really do have to have the message history. But with the thread, essentially what happens, so we add messages to our thread. You see, I just clicked enter, it didn't do anything. That actually is a strong case. Something that you can see is we might type this. We can add that message to a thread. I will say that this playground is being very temperamental with me. So when we created a thread, in that thread, it has an ID. And to that thread, we added a message. Still nothing has actually happened until we click run. Now this is actually sending that to ChatGPT API, and the assistant is returning a response. Within the actual thread, you can upload files, you can upload images. Okay, so think about all those pieces, and you have to think about them really quickly because we only have 4 minutes. But we're going to look at how this looks again programmatically. So one, we have these global things that are available at the assistant level. We have enabling file search, enabling code interpreter, enabling functions. We need to pass in files, and functions, all right? Global level. Otherwise, we can have multiple threads of conversation that are actually distinct from the assistant. At any given time, all we ever need to do is send one single message to a thread because it remembers everything. To a thread, like the one conversation that we are having with the assistant, you can add files. You can add more files. You can run, and you can add individual messages to a thread and then run them. That is precisely what it looks like in this code. So right now we're using the same client as we had before. Do you remember how I just now had to create that assistant? So I had to give it a name, I had to give it instructions, I had to click buttons about whether I wanted to use code interpreter or file search. Here we are again. I had to choose the model, exactly what we just did. And here goes the assistant. We also, did you see that when it hung for a second, when I sent a message, that's because it had to create the thread. It created that thread, and that thread has an ID. What we saw was that when I typed a message and clicked add, or that plus button, that is when I added a message to a specific thread. So I needed to create that message, and then I added it to a particular thread, and this would be the contents of that message. Whenever I wanted to actually send this message to the API, I click that run button. So yes, it is called a run in the API. And here is how you can do it in a non-streaming way. What did we run? We passed in that thread that had the new message in it. And we have an assistant, particular assistant that we want to utilize. We can add any individual instructions to that run. We wait to see when it's done, and then we get information out of it. Here, basically below, you'll see how we can use things like code interpreter and how we can use the vector store. If you run these on your own, they'll download some different files. And then essentially we use the files API to send information back and forth from OpenAI's file system to either our assistants or our code interpreter or our tools or whatever have you. So take a look at this on your own. Essentially, it's there for you. The Assistance API is, if you look at it, you will find that probably it is more agent-based, has more agent behavior than it does with completions behavior. We already saw that it uses tools. So congratulations on your second week, completing your second week. It was very programmatic, and I know this was some of y'all's first times, and I'm excited that you stuck with us through it. Do remember that next Thursday we have AWS Training Day, where AWS will come in and train us how to do these same types of things using AWS Bedrock. You do need to sign up and let us know if you need the form, but it was provided in the last email. Otherwise, next week, we're going to talk about training. We've said a little bit about cases of when you want to train, but next week we'll tell you how exactly to do it. Thanks for coming, and I'll see y'all next week. Bye. All right, if you have questions, I'm happy to answer. Shoot.
Hey, I have a question for the message history.
Yes.
So in our code, I
Mhm.
find the message history and session ID are always defined outside of the response function.
Yeah.
So I'm wondering, in practice, should we declare them as global variables in the program?
So this is where it gets into software engineering and design a little bit, because what it really should be is stored in the database somewhere, especially the session ID. So the session ID, like that is, so like when when you go to ChatGPT, it has like the sidebar. Like it's very unlikely that there's some program where that's a global variable because there's like a million users. So really that should, and you see how literally every single thing with these APIs has an ID, like that really should be stored in a database. It should be retrieved per user. In terms of the message history, it's the same. So usually with the message history, what you would actually do, the better way that it's represented is in Wednesday's notebook, but essentially like you might have a session ID, but you look up the conversation or create a new conversation based on that session ID. So you get the history from that session ID, which really ideally would be stored in a database elsewhere.
Okay, thanks.
Oh yeah. Other questions?
So, Miranda, I don't know if we should kind of wait until other people have questions, but I wanted to show you a general, just a generic proposal that we have, and then talk about how I could develop like a platform for it to, if I upload like an RFQ, how it can take the generic proposal and make it specific to that and get it to like 80% and then reduce staff time and elevate the project descriptions that best meet that RFQ, and then kind of reduce the priority of other former projects that don't really meet, that don't align well with the RFQ.
Yeah, why don't I'll create a breakout room and then we can just like discuss and office hours can discuss.
Sure. Yeah, that would be great. Thank you.
Mhm. Okay, so room 1, are you able to put yourself in there? Oh, open room. There we go. Okay.
Awesome. Thank you.
I wonder if they want to just have a separate meeting.
Yeah, I think we could probably just hop off and the room will still stay open.
Oh, so do I Who's the, I can assign it to Miranda.
Perfect.
All right, I'm about to assign and leave. Thank you guys so much for today. You guys are amazing.
Thank you. This was really awesome today. I learned a lot too.
Yeah. So glad to hear it. I'm gonna go. I'll see you later. Bye.